Hello everyone, we're going to start our lesson today with asking this question. So the question is, what is the meaning of this sign? Would it be number 1, 2, 3, or 4? Icy road ahead, steep road ahead, curvy road ahead, or trucks entering highway ahead? Well, let's see what you picked and see if it's correct. So this sign actually refers to steep road ahead. So it has to do with the incline of that triangle where the truck is driving down. And that's kind of what we're going to be focusing on today, the steepness of something, which is going to go back to what we've been talking about in the past. So let's say there was a 7% sign on that sign. What does that 7% mean? So the 7% is just the slope of the road or the steepness of the road. So it has to go back to slope, which is this thing we've talked about before. And it pretty much means that the road drops 7 feet vertically or up and down for every 100 feet going across side to side horizontally. So again, 7 feet down versus 100 feet across, that's what this 7% means on this sign. So what is slope? Again, slope is just the steepness of a line, the incline of a line. So we're going to get into how to find slope. So we've done this in the past. We've gone over how to find slope in a line, in a table. But again, the slope is just the rate of change of the line. How much is it changing vertically and how much is it changing horizontally in comparison to each other? So that's the rate of change of a line. And again, like I said, we have done this before. So we're going to start with our first table. But before we do that, let's go ahead and fill in the blank on our paper. All right, so here we have another way of seeing slope. The slope of a line measures the steepness of the line. We're familiar with the word slope as it relates to mountains. So you've heard people refer to that in terms of they're going to ride down the slopes of the mountains. So skiers and snowboarders refer to hitting the slopes. Slope measures the ratio of the rate of change of the y value, so the vertical direction, versus a change in the horizontal direction. So let's go ahead and look at these tables. We've done these before. Okay, for our first table, just as a review, remember the rate of change is how much is changing in the vertical direction, which is the output. And in this case, we can see that there is a change of 3. It's growing by 3. And then we also want to look at the output in the horizontal direction. The input in the horizontal direction, which in this case is 1. And this is our starting value, which is -5. And then we write our equation, y equals 3x minus 5. Remember, the one next to the variable is the change because that's the one that's going to multiply by 3 because we're repeating the adding of 3. All right, let's go to number 2. Go ahead and try it and then come back to the problem. So the difference here is it's written in function notation. So maybe, hopefully, you guys remember to write that out. So again, the change in the output is -6. Doesn't matter where you put your little arrow for the change, and the input change or the horizontal change is growing by 3. If we divide -6 and 3, we get -2. Our starting value is at 14, so when we write our function, we have f of x equals -2x plus 14. If you wrote y equals, that's fine, but try to make sure you do function notation when it's indicated. All right, so again, slope again, rate of change of a line. So we sometimes refer to it as rise because it's the vertical change over the horizontal change over run. Or the little delta sign of y over delta sign of x. In mathematics, we refer to the delta sign as change in y over change in x. Please write this down. Change in y over the change in x, or in easier terms, rise over run. So as we work with slope, there's going to be 4 ways you're going to be expected to know how to find slope. By just looking at the equation, which is actually the easiest one, from a table, which we just went over, from a graph, which is we're going to cover today, and from 2 points. So fill these in and pause if necessary. So we're going to go over a graph today. All right, so slope from a graph. So the general idea to find the slope from a graph is using the general formula of rise over run, again, which means how far up and down it goes, run, how much it goes sideways. So again, always y versus x. So here's just a general problem which you do not have, so just kind of follow through. So when given the graph, it's easier to apply rise over run. Instead of using a formula, we use like a general formula of just counting. So start with the point on the left and count how much you rise up and or down, and then get the other point, get to the other point. So in this case, I would want to rise from this point on the left up 3 units and then across, and I would count that to be 6 units. So in this case, I rose 3 and I ran 6. In other words, 3 over 6, and then all fractions need to be reduced if possible. You will be reducing as a fraction, not as a decimal. So we're going to stick to fractions here, or whole numbers if it divides nicely. In this case, it's 1/2. All right, let's go ahead and do our example now with the actual graph and the ones you're going to write down. So let's go ahead and look at that. So we're going to go ahead and see this problem. We have the coordinate pairs on it. We're going to go ahead and count the rise. So I'm going to go ahead and draw a line from the point going up. It's not there yet. All right. So we're going to draw a quick little line. I'm going to be going up here and then across. So I'm going to count how many units it goes up. 1, 2, 3, 4, 5, 6, 7. So it goes up a total of 7 units. So I'm going to write down 7 here. And then I'm going to count how much it runs. 1, 2, 3, 4. So that's going to be a total of 4. So my slope for this line will be m. We use the letter m for slope. So rise over run. So 7 over 4. So go ahead and try the next 2 problems on your own and come back and check your answers. So let's check out how well you did on number 2. So here's what little triangle you should have. The rise should have been not just 1, but hopefully you remember that it's -1 because you went in the negative direction. And the run should be 7. Went to the right, so it's in the positive direction. So my slope here should be -1 over 7. You cannot reduce this fraction, so we're done. Let's go ahead and check out your next answer. So we should have the triangle that looks like this. So rise over run here. So in terms of rise, we should have gone up 5, which is +5, and ran once, which is +1. So your slope in this case should have been +5 over 1, which simplifies to just 5. So now we're going to get into the slope of horizontal and vertical lines. Their slopes are slightly different than the regular slope of a slanted line. So these are 2 that kind of get confusing for some students. So let's kind of make sure we get these down so we won't have those errors happening. So here we have a horizontal line. I'm going to just pick 2 random points. I'm going to pick 2 to the left of the line and let's say 3 to the right. So I'm going to pick those 2 points. I'm going to find the slope. So in this case, you can see it just goes across. There is no rise and going up or down. So in this case, when I find my slope, there is no rise here for this line. So it's going to be 0. And you can think of the run as just being from point to point. So the run in this case will just be 5 units across. 0 over 5. And 0 divided by 5 is just 0. So horizontal lines have 0 slope. So one more time, all horizontal lines have 0 slope because there is no rise in them. So all horizontal lines have 0 slope. So it's just constantly across. Versus, let's look at a vertical line. Let's go ahead and calculate that number. So we just kind of want that. All right, so a vertical line, let's go ahead and pick some points on it. Let's pick 1 below, and let's pick 4 above. All right, so here's a vertical line. It does rise. It's rising a total of, in this case, 5. So slope, m is equal to 5 for the rise. Now the run, it has no run, which means the run is 0. But this kind of goes against the one rule in math that we cannot divide by 0. So we cannot divide by 0, therefore this right here doesn't exist. which means our slope does not exist. So we say this word undefined, which means defined is going back to the word definition. So there is no definition for the slope of a vertical line. So that's why a vertical line goes back to not being a function as well. But undefined slope, which means it has no rise to run value because it doesn't run. So vertical lines have an undefined slope, which is different from zero slope. All right, so that's pretty much it for today. Go ahead and start your practice problems, work on IXL, and good luck.